Hey, what is up everybody? Today we are going to take a closer look at how I made the speeders move in the Endor Speeder Chase set that LEGO recently released. If we take a look at the finished model, you can see that as I turn the crank, the speeders will strafe from side to side, and they tilt a little bit as they do, which gives a nice sense of them flying or hovering or whatever it is they do through the forest. If you've seen some of my previous work, you might recognize the movement as being very similar to my Pursuit of Flight model and the variations that I've built throughout the years. I've actually wanted to build a Star Wars speeder version of this model pretty much since I designed the original. So when this set was announced earlier this year, I was really excited to pick it up and see what I could do with it. One big difference with this model is that the mechanism is mounted at an angle. I wanted to keep the speeder bikes in the same orientation as in the original model, which required mounting the mechanics off grid, which actually turned out to be a lot easier than I thought it would be. So how does it all work? Here we can see the core mechanism with the trapezoidal arrangement of bars so that the upper platform tilts as it moves from side to side. I have shortened the supports so that the speeders will be closer to the ground, and I've actually brought them a bit closer together as well. But it is essentially the same mechanics as in my other Pursuit of Flight models. And I do have the front and rear supports offset by 90 degrees on the drive axle, so the speeders will move out of phase from each other. The mechanics are contained in this independent layer that sits beneath the main model. And here you can see the angled mechanism sitting inside the frame. And I'm actually using a really easy technique to get this mounted at an angle. By exercising our basic geometric knowledge, we know that the distance between opposite corners of a rectangle are equal. So the distance between these two corners is equal to the distance between these two corners. So if we take another plate, we can overlay it and rotate it so that these two corners are in the exact same position as these two corners of the plate below. So instead of placing a plate into a frame on grid like so, I can rotate it and tie the opposite corners into the grid using hinge plates. And the mechanism for this model essentially sits on an 8x16 footprint and is tied into the frame in the exact same way. And this technique can be used with plates of any size to mount things at different angles. Here are examples using a 1x8, 2x6, and 2x4 plates. The drive shaft running from the crank on the side of the model is on grid, and I'm using a couple of bevel gears to transfer the rotation to the mechanism, as they can be meshed together at any angle. I did have to make some modifications to the original set, but they really only affected the ground layer. Instead of the 3 8x16 plates for the ground, I'm using an assortment of regular and wedge plates to build the angled slots for the speeder supports to move through. I also changed the color from medium nougat to dark tan because I had a larger variety of parts available in that color. And it turns out most of the ground cover is away from where the slots are, so I only needed to move a few ferns and leaves from the original layout. The original model can now sit on top of the mechanical layer with the speeder supports coming up through the base. We can mount the speeder bikes on top of the supports, and that is pretty much all there is to it. I am really happy with how this model turned out, and I want to thank everybody who joined the live stream where I did the initial design for it. As always, thanks for watching, keep on building, and I will see you in the next one.